Okay, so our new chapter, chapter 3, is all about polynomial and rational functions. So what do polynomial functions look like?
More than one thing.
More than one term.
Yep.
Today's the third or fourth?
I was gonna do it over this album too, I just can't remember.
Okay, so yeah, polynomial functions, those are going to be functions with more than one term. So those are things that we're kind of used to saying. And then what's a rational? When we talked about rational numbers a while back.
Something that's reasonable.
No, sometimes.
It's like a
They're
number
real
that's
numbers.
not I or E or a number that's not irrational.
Okay, but what makes a number irrational?
I said
It's
irrational.
like 1.3 repeating.
That's a pretty rational number. But that would be 4 terms.
Anything that's not
Very
like
7.
2 squared pi, they're not pi.
Right, so what's
Or the square root of 2.
like square root of 2 and pi, what do those have in common?
There's got a bunch of repeating numbers.
Right, then they keep going and going and going and going and going,
Yeah.
which means that we can't write them as what?
Fractions or something.
Fractions. So yeah, irrationals are things we cannot write as fractions. So what are rationals?
Anything that's not irrational.
Which means we can write them how?
As a
Right. So these are going to be functions that are written as fractions. Yes.
Don't they have to be real numbers too? Like they can't be I or
Right.
stuff.
Yeah, it has to be able to be written. So in general, rationals are numbers that are able to be written in the form of A over B, where A and B are both real numbers. And A and B are actually integers.
Because can't you have like I over 1?
Right, but I is not a real number.
Yeah, I know, that's why I was asking if like real
Right.
numbers. Because I know you could write them as like fractions.
Right, where the top and bottom are both integers. Okay, so our first section, they're going to be the polynomial functions that we know the most about at this point, that you guys are the most used to dealing with, quadratic functions. So how do we know that something is a quadratic function?
It's got 4 of something.
No.
Squared.
Right, that's when we see that we've got which variable being squared, the x or the y. Right, when we've got an x squared, that's when we're going to be dealing with quadratics. So what does the graph of a quadratic look like? Because we're going to be dealing with graphs a lot. Right, a parabola. So that's what we're going to look at first, are some of the features of the quadratic function graph or the parabola. All right, so all parabolas, whether they open up or open down, have a really important point that's either the highest or the lowest point of the parabola. What's that called?
Min or max. Minimum or maximum.
Well, yes, but more specifically, the ordered pair is called the
Vertex.
No,
Vertex.
it's not vertex,
All
my
right.
bad. I'm close. I know what we're talking about though.
It's been a long weekend.
It has been, yeah, that unexpected 3-day weekend catches up with
It was
us.
a 5-day weekend for me. I was so.
I came to school for
Don't
one
brag.
day.
One day.
No, I'm not bragging.
All right, so yeah, that vertex, we're gonna give it the ordered pair of HK because we're gonna see the standard form equation in a minute, and that's the ordered pair for our vertex. All right, there's something else that's really special about it. We've got that dashed line going through the vertex. What's that called?
That's the axis.
That is indeed the axis of symmetry. And what would the equation for that line be?
X equals Y.
I like the x equals part.
X equals a number.
Right, but we can actually say a little bit more specifically what that number is here.
Isn't it
H.
X equals 8?
It would be x equals h, because yeah, it's going to go through that, through our vertex. So it's got to be x equals whatever the x coordinate of the vertex is. All right, so one other thing. Our parabola is either going to open up or open down. How do we know what's going on by looking at the equation? Yes?
There's a negative in front of H.
Not in front of h. You're heading in a really close direction though.
X.
Right, so there would be a negative in front of your x squared, or if it's in factored form, you're going to have a negative out in front of that parenthesis. So a negative, would that mean that it's open up or open down?
I'm so good.
Well, we'll see in a sec.
Okay.
So yeah, we're looking for a negative in front of our x squared, or like I said, the factor form. In this case, it's going to be positive in front of the x squared, or the factor form. All right, so just like our circle had a standard form equation, parabolas are gonna have standard form equation. That's the form we really, really like because by looking at it, we get a whole lot of information without actually having to do anything. Okay, so standard form, again, looks very notationally heavy, but it's really not too bad. So here is our standard form equation for a quadratic function. So we've got f of x equals a times the quantity of x minus h squared plus k. So we've already identified some of the information from that. So the big deal is our vertex. In my opinion, most important point on the parabola. It's the ordered pair HK. So here's where we have to be a little bit careful. We've got a negative built into our standard form equation. Just like we did with our circle, when we were looking for its center, we had to switch the signs. We're going to have to do the same thing here when we're looking for the x-coordinate. So now, here's the annoying part with this. We don't switch both of the signs because look at what's in front of the k. It's got a plus. So we're going to have to remember to switch the sign on the x, but leave the sign on the y alone. All right, so yeah, we already talked about our axis of symmetry. It's that lovely vertical line that goes through our vertex. It's always going to have the equation x equals h. So if you correctly identify your vertex, the equation for that axis of symmetry should take you like half of a second. All right, and then that last part is what we were talking about last there. If our a is greater than 0, so if the number in front of that parenthesis is positive, then our graph opens up. If the number in front of our parenthesis is negative, so if a is less than 0, then our graph is going to open down.
What if it's 0?
Okay, well it says here that we can't have a be 0. Why not? What would happen if our a was 0?
Because then you just get k.
Right, that whole a times the parenthesis would be 0. What would our equation actually turn into then?
A line.
Right, what kind of line?
Horizontal.
Very nice, a horizontal line, because it would be y equals k, which would definitely just give us a horizontal line, not a quadratic. So yeah, our a is either going to have to be positive or have to be negative. It can't be 0 here.
Oh, I can't go. Oh.
Can you come to the concert?
No, I'm
And this
just
is
I have to babysit 3 on my kids. I don't know.
Bring them to the concert.
I'm getting paid for 5 hours of babysitting, and I only have to watch them for 2 hours.
Okay, so first thing we're going to do is just figure out what would the vertex of our parabola be. So we've got our nice quadratic function here. It's all happy and factored. We're going to come up with its vertex, and just for a little added fun, we're going to figure out what would its axis of symmetry be, and would it open up or down.
So when you say just for fun, you mean you're going to be doing this later, so we're going to do it now?
It's something we're going to have to need to know later, so might as well get it out of the way.
Okay.
All right. So our first equation, we've got f of x equals 2 times the quantity of x minus 3 squared plus 1. So what would the x-coordinate for our vertex be here?
-3.
No,
Nope, just
3.
Oh,
Yeah, that's the one we've got to remember to switch the sign on. Okay, and then what about the y-coordinate for our vertex? Positive 1. Okay, so our vertex is going to be the point 3, 1. What would our axis of symmetry be here?
3.
I need an equation.
X equals 3.
X equals 3. There we go. And would this parabola open up or open down? Up. Why would it open up?
That's greater than 0.
Right. The 2 out front, our A, is definitely greater than 0. So yeah, this one would open up. Alright, so then below that, we've got f of x equals a -2 times the quantity of x plus 1 squared plus 5. So what would our vertex be for this parabola?
-1, 5.
Yeah, -1, 5. Okay, what would our equation for our axis of symmetry be?
X equals 1.
X equals -1, right? And then would this parabola open up or open down?
Down.
Yeah, because we've got a -2 hanging out up front, it's definitely gonna open down. Alright, so what do we think? Yes, sir?
So you change the sign on the.
You changed the sign on the H, but not the K.
Not the K.
Yeah, because the K had a plus K built into the equation, so we don't have to mess with the sign. Alright, so what are we thinking about identifying things with parabolas? Anyone? 2s, 3s, 4s, 5s.
She said 5.
What? Oh,
So
oops.
proud.
There goes my notepad now.
Okay, so now we're gonna look at how would we graph these delightful little fellas, because I know everyone just loves graphing so much.
Yay.
So, first thing you're gonna wanna do, just to kind of give you a general idea of what your parabola should look like, figure out, is it open up or open down? So another way, a little bit more technically correct way of saying that, is it concave up or concave down? Sounds a little bit more impressive that way. But it's the exact same rules. Okay, so then, once we figure out, is it concave up or concave down, we need the most important point, we need its vertex. So determine what the ordered pair for that vertex is. So then after we figure out the vertex, there are a couple of other really important points. Or I should say there are often a couple of other really important points, are x-intercepts. So not every parabola will have x-intercepts. Our graph does not have to cross the x-axis, but if it does, we should know exactly where that happens. So in order to find your x-intercepts, what you're going to have to do is set your equation equal to 0 and solve. So you replace f of x with 0 and figure out what x's would give you a y of 0, because that's exactly where you're going to be on the x-axis then. So you won't necessarily get x-intercepts, most of them will have them, but not all parabolas cross that x-axis. So then there's another very important point, your y-intercept. So is every parabola going to have a y-intercept?
No.
Yes.
Yes.
Of course. Because remember, your parabolas keep going and going and going and going and going. So what's the domain of the parabola always going to be? All reals, which means you've got to have an x of 0 somewhere. It might not be at a nice integer value, but you're somewhere you're going to have an x of 0, which is going to give you a y. All right, so yeah, that y-intercept, that's the easiest one. Put in 0 for x, simplify it. And then that last step, whenever you're graphing, you need to have at least 4 points besides your vertex. So if you've gotten 2 x-intercepts and your y-intercept, that's 3 of your 4 points. You can then use that axis of symmetry, reflect your y-intercept across, and there's your 4th. So if you had to actually find those intercepts, that'll usually cover all the extra points you need. But if you didn't have any x-intercepts, you're going to need to find a couple of extra ones, just so that you really get a good idea of the shape of that parabola.
You've got exactly 1 minute to your timer.
I know, I've been keeping an eye on it. So I think we'll actually stop it here so that I'm not like in the middle of a graph.